Welcome everyone to our virtual complexity colloquium. It's my pleasure to host today Philip Ball. He's a freelance writer and author, and he has worked for many years as an editor of Nature. And he has several books which are highly recommendable. Several of them are related with complex systems. For example, Critical Mass, which won the 2005 Avanti Science Books Prize. Beyond Weird, How to Grow a Human, which I'm listening as an audiobook right now. It's very interesting. And he will speak about one of his next books, because he has 3 books out this year. But this one, The Book of Minds, will be published early next year. So please, Philip, it's a pleasure to have you here.
Thanks very much, Carlos. Okay, let's see if we can get this underway by sharing my screen. There we go. Okay. Yes, well, thank you very much, and welcome. Hello to all of you. It's very nice to be giving this talk as part of this fantastic series that Carlos has set up. I want to start with a paper that was published in 1984 by the computer scientist Aaron Sloman, and I've got it here, or I will have when I can. Okay, let me try this. Here we are. So this is the paper, and it argued that some systematic thinking should be brought to bear on the vague but intuitive notion of mind. It was time, Sloman said, to admit into the conversation what we've learned about animal cognition, as well as what research on AI and computer systems up to that point was telling us. And as you can see, Sloman's paper was entitled The Structure of the Space of Possible Minds. And he wrote this. He said that clearly there is not just one sort of mind. Besides obvious individual differences between adults, there are differences between adults, children of various ages, and infants. There are cross-cultural differences. There are also differences between humans, chimpanzees, dogs, mice, and other animals. And there are differences between all those and machines. And part of the task of mapping out this space of possible minds, he said, was to survey and classify the kinds of things that different sorts of minds can do. And he said these explorations can be expected to reveal a very richly structured space, not one-dimensional like a spectrum. There will be not 2, but many extremes. So this was a project for, among others, anthropologists and cognitive scientists, ethologists and computer scientists, philosophers and neuroscientists. Sloman felt that AI researchers should focus less on the question of how close artificial intelligence or artificial cognition might be brought to that of humans, and more on learning about how cognition evolved and how it manifests in us and in other animals. And this blending of computer science and behaviorism must have seemed a bit eccentric in the 1980s, but today it looks astonishingly prescient. Yet, although this cartography of the space of possible minds has still scarcely begun, there's never been a better time to consider what it might look like. Not only has AI at last started to prove its value, but there's a widespread perception that making further improvements and getting anything like an artificial general intelligence will require a close consideration of how today's putative machine minds differ from our own. Understanding of human cognition too has boomed in the past decade, and of animal cognition has boomed in the past 2 decades, in part because of the new possibilities that neuroscience and information technologies have opened up. Child psychologists now routinely talk to roboticists and computer engineers, and neurologists talk to marine biologists. We have some of the conceptual and the experimental tools to start mapping this landscape of minds. Well, first of all, we need to ask, I think fairly obviously, what is a mind? And there's no scientific definition that will help us. Much of the vast literature on the philosophy of mind barely defines its terms at all. It takes for granted that what we're talking about is us. Daniel Dennett presents a nuanced exploration of what non-human minds might look like in his book, his 1996 book, Kinds of Mind. And yet he too begins by saying this: whatever else a mind is, it is supposed to be something like our minds. Otherwise, we wouldn't call it a mind. So mind is one of those concepts, like intelligence, like thought and life, that sounds technical and therefore definable, but is in fact colloquial and irreducibly fuzzy. But I don't think that a workable definition of mind needs to be impossible, so long as we accept that it's going to lack scientific and philosophical rigor. So I would put it like this: for an entity to have a mind, there must be something it is like to be that entity. So I don't believe that a rock, say, has a mind, because I don't think that a rock has experience. I don't think it means anything to say that being like a rock is to be anything at all. How about a bacterium? Is there something it's like to be a bacterium? Well, here opinions are slightly more divided. But in any event, at some stage on the complexity scale of life, there must have arisen entities for which there is something it's like to be them. I imagine that most people are ready to accept today that there is something it's like to be an orangutan. But yeah, and you might well consider that there's something it is like to be a mouse, perhaps even a fly. How about a fungus? Maybe that's pushing it. This is why it makes sense to speak not in terms of things that absolutely do or don't have minds, but to speak of mindedness, to acknowledge that minds are not all or nothing entities, they're matters of degree. And let me illustrate this by showing you a couple of previous efforts to say what this mind space might look like. A simple but ingenious way to draw that map was devised by the American psychologists Daniel Wegner, Heather Gray and Kurt Gray in 2007. And they simply asked people about other minds, about what attributes people think those minds have. They questioned around 2,500 participants about the perceived mental capacities of humans, animals, and other entities like robots, companies, and supernatural agents like ghosts and God. Surprisingly, the responses could be boiled down to a space of minds that had just two key attributes, which they labeled experience and agency. So here it is. Experience means how much inner life the mind has, a capacity for things like hunger, fear, pain, pleasure, and joy, or more generally, a sense that it feels like something to have that sort of mind. Agency, meanwhile, refers to the ability to do things and to accomplish goals, which might mean to possess memory, to be able to plan and communicate. So this is a space really of possible perceived minds, what we humans imagine the dimensions of mind might be. And it can be displayed as this two-dimensional graph on which each entity is represented as a data point with a certain amount of experience and agency. So those entities that have non-zero quantities of either or both of these attributes are, according to Wegner and colleagues, ones that we admit to the Mind Club. And humans are evidently regarded as following a path in this space during the course of their lives. So babies, represented here by this pacifier up in the top left, they were rated on average as slightly higher in experience, but much lower in agency than adults. So everything for a baby is intensely felt, but they don't get much done. Children are intermediate between the two. Curiously, even when we die, we're not deemed to return to the origin, so to speak. Dead people were attributed less experience than fetuses, say, but not zero. And strikingly, they were assessed as having rather more agency than people who were still alive, but in permanent vegetative states. That's the PVS man here. If entities can feel, if they have experience, then we tend to grant them moral rights. We consider that we have a duty to recognize and respect that experience. If, meanwhile, they have an ability to act, to cause change in the world, then we're likely to give them moral responsibility, a duty to execute those actions in a way that respects moral rights. By this measure, humans incur both moral rights and moral responsibilities. Interestingly, we seem to perceive robots as having responsibilities, but not rights. You might say that it matters what they do to us, but not what we do to them. And that perception stems from our view of the manner of mind that they possess. Now, another attempt to plot a space of possible minds was made by the neuroscientist Christoph Koch. His mind space is also two-dimensional, and it has coordinates of intelligence and consciousness. So again, humans exhibit the greatest simultaneous component of both of these attributes, and other animals have some degree of them, although primitive creatures like jellyfish don't have very much. And they seem to increase in proportion to one another on the diagonal of this plot. Today's computers and artificial intelligence systems do well in terms of intelligence, but have negligible consciousness. And in Koch's view, that's unlikely to change anytime soon, or perhaps ever. And you might notice that humans, as I say, appear at the top right of both of these plots. They're presented as the exemplars of the key attributes of mind, and all other minds are then being assessed according to how they compare with us. Well, that's just the way we are, right? So let's start by thinking about the human mind, not to cut it down to size, but to get a clearer view of the landscape that we're in. I want to challenge right away the notion that the human brain is a kind of computer or information processor, and that mind is a kind of algorithm for turning input data, sensory experience, into outputs such as actions. That's a view that's encouraged by many experiments in behavioral science, which present stimuli to the brain and then measure the result. That, of course, is a highly artificial situation. Ordinary behavior is quite different. It's much more fluid, much more contingent, and much more fuzzy about its goals. The philosopher Ned Block suggests that there are two key components or attributes of the human mind: intelligence and intentionality. Intelligence is an information processing capability that turns a stimulus into a behavior, while intentionality supplies the purpose and the motive for that behavior by relating it to the world. And this means that the intentional system has to have states that represent, that are in some sense about that external world. Dennett argues that to have intentions means that a mind must be a generator of expectations and predictions. What else is an intention but a wish for a certain outcome of events in the future? So Dennett says this about them, that he says that the mind, the human mind, mines the present for clues, which it refines with the help of the materials it has saved from the past, turning them into anticipations of the future. And then it acts rationally on the basis of those hard-won anticipations. And yes, that word rationally raises a lot of questions, but we'll have to shelve those. This view of the human mind as a predictor suggests how, in fact, it differs from a mere stimulus response system. Sure, you can imagine making a machine that is given, or that develops, some intricate internal model of the world around it, and then given a goal and a set of stimuli, does some massive computation to predict the optimal action for achieving that goal. But do I need to point out to you that our minds are not like this? That our decisions and predictions are often rather poor at attaining our goals? That most of the time we're not really sure what the goal is, or rather that we have many conflicting goals and not the slightest idea how to calculate a route amongst them? No, evolution didn't build our minds this way. It's not clear that it ever could, that our complex environment could ever be reduced to a well-defined optimization problem, or that even if it could, we could solve it fast enough not to be eaten. I hope we might agree that minds evolved, whether by degrees or in jumps isn't clear, but evidently that's how our minds came into being. I suspect we might also recognize that mindedness seems to be most well developed in creatures that experience the most complex environments. What I'd suggest then is that our minds, as well as those of other animals, are not stimulus response circuits for creating actions, but are actually the alternative to that kind of automaton-like behavior. The simplest organisms, like bacteria, often show behavior that is hardwired, a very limited repertoire of actions that is generated reliably and predictably by stimuli from the environment. Now, we often vastly underestimate the complexity and the contingency of behavior, even in those cases, but I hope you'll agree that hardwiring is more evident and more salient in bacteria than it is in us. Minds exist to free us from that, if you like, to free us from our genes by allowing actions that aren't pre-programmed. The amazing thing about humans is not that our genes affect how we think and make choices, which of course they do, but how much of our behavior seems to escape their dominating influence. Complex minds have a vastly expanded behavioral repertoire that can be fine-tuned and adjusted and improvised to new circumstances. So if evolution wants, to put it much too teleologically, wants to give a creature so many behavioral options, then it can either invest a huge amount into hardwiring a response to every foreseeable circumstance, or, and this seems likely to be the most efficient route, it can build that creature a mind. But here's the odd thing, because the intelligence we're endowed with is surprisingly broad, and that's not a boast on behalf of my species. I'm the first to admit that to the idiocies that we routinely perpetrate, but it's frankly rather bizarre that a brain adapted on Darwinian tracks could be capable of producing the theory of general relativity. This is sometimes called Wallace's paradox, because it was Alfred Russel Wallace who pointed out this apparent redundancy of much human intelligence. And no one knows why evolution made such a cognitive investment in us. One prominent idea is that it was motivated by the mental demands our ancestors experienced when living in community with others, that what distinguishes us most in the animal kingdom is our social intelligence. To get along equably with our fellow beings, for example, we'll do well to anticipate how they'll behave in response to our own actions. We'll need some mental model of what their minds are like. Other evolutionary biologists think that maybe the richness of human cognition had less to do with a general ability to socialize and more to do with the challenge of finding a mate. That it was, in other words, the product of sexual selection. If you try to look up an image that will convey this aspect, you will not escape the cliches. So I do apologize for that, but I think it makes the point. A complex repertoire of behaviors might persuade a potential mate that this individual is going to be good at the survival game. In this view, human intelligence might become a bit like the peacock's tail or the stag's antlers, a trait that got blown out of all proportion relative to what is strictly needed. And if the idea that our sex drive made us more intelligent sounds perhaps surprising, just remember how much of our cultural and creative energy is still motivated by it. Others think that the key to human intelligence is not so much biology, but culture itself, that our intelligence took off in parallel with our ability to pass on skills, learning and technologies to successive generations. After all, what arguably distinguishes us most from other animals is not our basic cognitive skills, but the complexity of our societies. And one of the biggest expressions of that difference is language. In particular, we can communicate complex ideas, not just from person to person, but across time, using language in verbal and written form. Many suspect that it was with the advent of language that the human mind truly began to outstrip that of other animals. Still, we're not sure what language is for. Maybe it simply allows us to convey useful knowledge to others, but another more striking feature of language is that it allows us to express things, not just things we've experienced, but things that we have never and will never experience, possible futures. We can imagine ourselves not only into all manner of possible circumstances, but also into lots of impossible circumstances, floating in the vacuum of space, living underwater, being an inch tall, traveling through time. This open-ended, imaginative kind of cognition might be just what was needed to cope with the greater part of human existence, what it's always been composed of, which is that choices of what to do never end and have no absolute right answer. So living isn't a computation, but a process. a constant flow of interrelated decisions and actions and emotions, some big, some small, some conscious, others less so or not at all. And the mind is more like a pilot than a computer. And the task of the pilot is not to solve reality, but to land the plane. What it needs to do that is a representation of the world it must navigate. And that means that we have to have a representation of the world that doesn't have to be perfect, but merely good enough. And likewise, for our decisions, they're not computations of some optimum action, which is likely to be very time consuming if it exists anyway. Instead, our minds must use shortcuts and heuristics to find ways to make decisions that are, we hope, good enough. The psychologist Elizabeth Spelke has proposed that we achieve this using a small number of core knowledge systems. One of these gives us the ability to conceptualize objects, that they're things that hold together as single entities which persist over time, whether we can see them or not. We also have a spatial system that can understand distance and orientation, that some things are nearer, some things are further away, some sit in particular directions relative to us. And other core systems deal with actions, our ability to affect things, and with number or quantity. And Spelke suggests that there's another core system that relates to social interactions. So it supplies the basis for our intuitive psychology, supporting the notion that there are other beings that act as agents with intentions and goals of their own, which might or might not align with ours. This is what psychologists call a theory of mind. That is not a theory of what minds are or how they work, but a sense that other beings have minds at all, and that they probably work like ours. So here then is what seems most to characterize the human mind. I think that it evolved to enable more diversity in behavior in complex environments than can be realistically achieved from a stimulus response hardwiring system. That it solves problems that are not computable, that it does so by constructing a representation of the world we experience, and from that constructing possible futures, and that it exists and knows that it exists in relation to other minds. Point 3 here then is achieved by having the kind of intuitive physics embodied in some of Spelke's core systems. Point 4 is accommodated by our intuitive psychology, our theory of mind. How does it accomplish point 2? Some researchers think that this is at least part of the reason why our minds have an emotional dimension. We're guided not by computing solutions, but by gut instincts about the best thing to do. And then there's an entire talk to be given on what emotions are about, but I think that in a nutshell, a strong case can be made too for them giving salience in the mind for things that seem to matter most or seem likely to matter most, and for being a part of the mind's internal representation of our physical body. At any rate, I'd suggest that here we have some sort of schematic outline for thinking more generally about minds, at least about the evolved minds that we know about. And it's worth pointing out that there's almost certainly not a unique best design for minds like these. So humans don't occupy just a single datum in mind space. They populate a region of it with diverse characteristics. Some of this might be just natural random variability, but it seems very likely that the neurodiversity of human minds is adaptive for the group, that we're better at solving communal problems using an array of kinds of mind. There is, of course, another core attribute of our minds that is surely central, although we don't know quite what relevance it has, and that is that our minds are conscious. And I've avoided that issue so far because, as you'll know, both what it means and how it arises, and indeed where it arises, are all controversial. And these questions are another talk or book in themselves. And all I want to say on the issue here is that we shouldn't imagine that consciousness is a single and well-defined coordinate of mind space. It seems likely that there are different types and modes and degrees of consciousness. And maybe to illustrate that, I'll turn now to some different kinds of mind. Darwin had no doubt that other animals have minds. He wrote that there are no fundamental differences between man and the higher mammals in terms of mental faculties. Few animal behaviorists would now dispute that at least some animals, especially primates, possess what we can regard as a mind, alive to sensation, to feeling, to emotion, and probably to some degree of consciousness. As with the human mind, animal minds have evolved to serve a function or to serve functions. And there is no attribute that an animal has that won't at some level depend on the evolutionary niche that it occupies. It won't just have a cognitive ability without a reason for it. The nature of the animal mind defines what the physiologist Jakob von Uexküll called its Umwelt. In effect, the world that the creature inhabits, characterized by certain needs, concerns, and capabilities. So the Umwelt reflects what stands out for the animal in its environment, which things it notices. Smell is a much smaller part of our Umwelt than it is for dogs. We're less sensitive to it, for sure, but also it means less to us. In the Umwelt of a slug, a lump of flint is, I'm guessing here, merely another obstacle to be navigated, whereas for our ancestors, it represented a potential tool. The Umwelt also includes things we recognize as objects. So for us, we'll recognize a woodland path, whereas for a vole, there are just open spaces, which are dangerous, and more vegetated spaces, which are safer. The Umwelt of, say, a European robin includes some kind of awareness, and we're not sure what that really means, of the Earth's magnetic field. And the Umwelt includes an organism's conception of intuitive physics, of things that it figures or believes can happen. It's from the Umwelt that a creature builds its conception of the world, and this is the organizational framework of its mind. What in the world that mind finds meaningful. The Umwelt of a flying creature, like a bird, recognizes spatial possibilities that are alien to us. But there's a surprising amount in the brains of birds that does seem familiar. In fact, the avian world is one of the richest natural repositories of other minds. The cognitive skills of birds are astonishingly diverse, and among them we find arguably the best claims for non-mammal consciousness, as well as examples of artistry that raise questions about animal aesthetics and some of the most complex vocalizations in the natural world, prodigious feats of memory, inventive tool use. I think we'd find bird minds scattered rather widely through the space of possible minds. The minds of the 10,000 or so bird species are surely less like one another than are the minds of people with different skill sets. Their attributes sometimes seem to be fundamentally distinct, to the extent that some birds will be mind blind to things that dominate the Umwelt of others. That even rather closely related bird species can show very different cognitive abilities illustrates that minds don't come as a package that is simply passed on with minor modifications down the evolutionary chain. Rather, they're strongly and intimately adapted to the specific evolutionary niches and strategies adopted by each creature. And one of the most striking attributes of some bird minds is tool use. So aside from some primates and elephants and cephalopods, birds are the only other major group of tool users. And the champion of avian tool use are these ones, the corvids, and especially this one, the New Caledonian crow. They show signs not just of using tools, but of designing them for the task at hand, and they keep them for reuse. And they seem even to develop local traditions of design and to refine them over time in a kind of cumulative technological change. How do they do this? It's possible that some animal tool use is guided simply by trial and error. They might rely less on building imagined scenarios, like, hey, if I use this stick, I bet I could get more bugs, and more on past experience of playing around with the object. So that, it's like sort of, oh, when I did this, that happened. But it's not all try and see. there do seem to be some general principles behind bird tool use based on a kind of intuitive physics. And these concepts are often probed by studying how birds try to retrieve food from within tubes by pushing on it or pulling with piston-like tools. Actions like these suggest that the animal has some notion, for example, that solid objects can displace other solid objects by force. A key question is whether tool use in birds implies that they see any causal connection between what the animal does and what they see as a result. It's the difference between an action that is understood to result to have a result in a sort of mechanical way, and one that's just correlated with the outcome in a sort of ritualistic way, where it's as though the action just sort of summons the consequence. In other words, it's the distinction between different modes of thinking produced by different kinds of mind. But tests of the causal understanding of tool use in crows show that this may not be a single monolithic cognitive capacity. Crows demonstrate what looks like causal reasoning in some tests, but not others. One of the key distinctions is whether birds can carry out multi-step tasks with an ultimate goal in mind. So in contrast to the common view that animals exist in a perpetual present, the ability to carry out multi-step tasks seems to demand some concept of future consequences. If I do this now, it'll let me do that later. This entails some representation of possible scenarios and their outcomes. And this sort of imagining of the future seems to be at play, for example, when birds cache their food. They leave little stores of food stashed around for future use. In one experiment with scrub jays, they were kept in cages divided into two compartments. And then each morning, the researchers moved the birds into one of the two compartments, one of which contained a breakfast snack and one of which didn't. And the experimenters allowed the birds to feed on nuts to their stomach's content in the evening before, and then to allow them to cache some of the remaining nuts in one compartment or the other. And the scrub jays always stored them in the compartment that they knew from past experience would otherwise be empty the next morning, just in case they were put in that one. It's hard to see how they would make choices like that without some anticipation of that future scenario. The big question is whether birds have consciousness, and one ingenious set of experiments seem to offer some evidence that they at least have some kind of self-awareness. And that's to say they know they know what they know, and they also know how confident they are about that knowledge. What such studies can't tell us, and probably can never tell us, is what that experience is actually like for birds, or in fact whether there's any what it is like at all. That's to say, those experiments can't distinguish between what's called access consciousness, which is forming an internal representation of an event or an experience, including personal knowledge about it, and phenomenal consciousness, which has a subjective feeling associated with it. If we want to explore further afield in mind space, the most intriguing minds in the animal world are surely those of cephalopods, such as octopuses and squid. These are invertebrate mollusks that diverged from the lineage of vertebrates 600 million years ago. That's before the Cambrian explosion. Octopuses possess memory, they possess problem-solving ability, they even have what looks like cunning and personality. They have a naturally exploratory nature. They don't recoil from unfamiliar experiences. They seem to inclined to engage with novelty in an open-ended way. They figure out how to unscrew jars, how to navigate mazes, how to fuse laboratory lights with a jet of water. They can escape from their tanks at the very moment their human wardens aren't looking. They appear to hoard items they find interesting, even if they lack any obvious use. The philosopher Peter Godfrey Smith says that octopuses, like us, seem to have a mental surplus. They have far more mental capacity than it seems they should need. If so, it's unlikely that that arose for social cognition because octopuses aren't social animals. So it's tempting to regard cephalopods as having rather oddly sophisticated means of expressing themselves while having rather little to express or anyone to express it to. Our habitual division into mind and body looks now to be rather unhelpful in understanding our own cognition, but it really doesn't seem to make any sense at all for cephalopods. The body has, if not a mind of its own, then certainly a set of proto-minds in each arm that seem to make their own decisions. So while the octopus does have a centralized brain in its head, more than half its neurons are in its arms, and some of those are gathered together in clusters that seem to have a rudimentary brain-like capacity and seem to operate more or less autonomously. So the limbs even seem to possess some degree of short-term memory. We're not even sure if the octopus knows what its limbs are doing. It may be that they lack any strong sense of self. Perhaps to some degree, they just watch their limbs perform as if they're watching another creature do something. So they challenge the notion that experience has to be a tightly integrated whole. To wonder what it's like to be an octopus might then depend on which part of the organism we ask. One theory is that the ancestors of cephalopods had two entirely separate minds, one for the eyes and one for the arms, that eventually merged. At any rate, cephalopod minds represent an entirely distinct evolutionary experiment in building minds from ours. And the common ancestor of humans and octopuses wouldn't have had much mind at all. It was probably a kind of flatworm, but it did have a rudimentary nervous system for coordinating its actions. So nerves had been invented by evolution by then. And in fact, nerve cells might be the building, they're the building blocks of biological minds, but that's probably not what they were evolved for. It's rather neurons may be cells that are adapted specifically for transmitting signals over long distances rapidly and precisely between cells. And they do that electrically, of course, building up and transmitting electrical potentials by controlling the flow of ions across their membranes. Some researchers suspect that this electrical sensitivity, what physiologists once called irritability, imbues nerve cells with the ingredients of sentience itself. So the informatics expert Norman Cook has suggested that a nerve cell, by opening up its membrane to a flow of ions that creates a voltage and supports an action potential, it breaks the hermetic seal by which living cells generally distinguish their interior from the exterior, and that this opening up to the environment is enough in itself to generate a kind of proto-feeling. So minds and brains and cognition are, in this view, an aggregate of atoms of sentience in individual excitable cells in these neurons. Cook, along with the neuroscientists Gil Carvalho and Antonio Damasio, have suggested that the excitability of nerves is then a necessary precondition for sentience. And the implication is that perhaps there might even be something it is to be like to be a single neuron. But neurons don't have a monopoly on communicating with each other. Other kinds of cell can exchange information, typically by passing small molecules, signaling molecules between them, much as neurotransmitters cross between cells at synapses. The question is when coordinated cell activity like this merits being described as truly mind-like. And some biologists are now arguing that mindedness is an inherent property of most, if not all, living systems. Plants, for example, do some things that minded creatures do. They have goals. They're flexible and adaptive in their means of attaining them. They make decisions, and sometimes they seem to do that by learning and by conditioning. Some scientists have argued for a new discipline of plant neurobiology, and have argued that plants can even experience something like pain, a kind of a feeling of aversion towards things that threaten their well-being and integrity. And here I'm showing the so-called sleepy plant, which responds to touch. As ever more evidence accumulates for the range of cognitive faculties that plants seem to possess, advocates of plant neurobiology say that to deny plants intelligence and even mind can look increasingly like the sort of special pleading that we once used to elevate our own species above all others. Some argue that mindedness is in fact a fundamental property of all living things. This is a position called biopsychism. And in this view, all organisms have minds of a sort merely by virtue of being alive. Well, I'd argue that what plants surely do show is agency, the ability to act on the environment and on itself in a goal-directed manner that's not fully prescribed by stimulus response rules. So the claims of biopsychists and plant neurobiologists seem to me to be trying to fill the gap that's left by our lack of a good understanding of how agency arises in biology and beyond. Not all agents have minds, I think, but all minds do have agency. And I'd argue that one obstacle hampering our understanding of what minds are is a lack of a proper theory of agency. And that's something I argued for in this article. Well, then, I hope you might see that if these considerations of mind are right, then not only have we not yet come close to making machines with minds, but we're not even heading in the right direction to do that. Early predictions that AI would achieve fully intelligent machines within a few decades are now seen as motivated by really a woefully inadequate view of what human-like intelligence and cognition really are. The fact is, the fact that it was, and even sometimes still is today, seen to attain its highest expression, that human cognition found its highest expression in a game like chess, says it all, really. Or perhaps it says a lot about the people who were behind the steering wheel of early AI. It's often said that today's AI finds easy what we find hard, and vice versa. And in particular, that AI lacks what we'd regard as common sense. I think a better way to express this is that AI uses a different mode of cogitation. You might even say a different mode of mindedness. What we call common sense is largely an adaptive, intention-driven form of behavior, motivated and informed by our internal representations of reality, by our intuitive physics, by our intuitive psychology. These aren't things that seem likely simply to appear in AI if we go on making it more complex, giving it more processing power, more sensory inputs, more layers of deep learning or whatever. They have evolved in us for adaptive reasons. And if we want machines to exhibit them, then we're likely to have to put it in by hand. Perhaps one of the most interesting questions is whether these things can arise in machines without any degree of self-awareness. We can certainly imagine making excellent deep learning mimics that, once trained on enough data, can pass the Turing test in human conversation or in debating contests, while remaining zombie machines without a flicker of consciousness. In fact, arguably, we're at that point already, or soon will be. What's less clear is that machines like that could ever be more than one-trick ponies, devices built for a single task, or at best for a narrow range. If we're to overcome their narrowness, their brittleness, their vulnerability to what look like absurd mistakes or misjudgments, that might not come from simply making a few tweaks. It may be that for that, they will need to be entirely different types of device. And that, at least, is what some AI researchers are starting to suspect. You may have heard, and I strongly suspect that Melanie Mitchell said something very similar in her talk in this series. Well, I wish that I could wrap up now by drawing you a picture of mind space and pointing to our place within it. But such maps as we can currently offer are a bit like medieval maps of the world. So reasonably reliable in our neighborhood, a bit sketchy in the lands bordering ours, and little more than guesswork for distant realms where perhaps we might depict fabulous beasts that we're not sure exist at all. The best I can do right now is to suggest some of the possible parameters of this putative and multidimensional mind space. So here they are. And however unsatisfactory the effort, I hope at least that it helps us refine our notion of what a mind is. if I were to pick one central notion for what characterizes mindedness, it would be this: minds seek what is meaningful to them in the universe. The strange but inevitable truth about the nature of reality is that it doesn't have a unique form. It has to be interpreted. And what the human mind perceives is not the world, but a reduced internal representation of that, which is useful to us. Our meaningful information, our personal reality, is selected from much, much more that is out there. Selected, of course, not arbitrarily, but in a way that aligns sufficiently with what really is out there in the physical world to enable us to get along within it. Our minds ascribe this meaningful information value. What is more meaningful, because it's more useful to us, is awarded more value for us. And it may be that the emotions are partly what help us to construct and calibrate that value scale. So what determines the topography of mind space? Where, for example, is it populous and where is it barren? We certainly don't know the answer to that. We barely understand the question yet, but it's surely not an arbitrary question. I think it's the case that that this mind space will permit some kinds of mind, but not others. Nature, after all, never draws from an infinite palette of choices. While our minds and those of other animals were produced from scratch according to evolution's strategy of trial and error and selection, it operated within constraints. So it's reasonable to think that minds, at least on our planet, come from a space of possibilities in which certain attributes are indispensable or inevitable, maybe some degree of memory or a limited range of sensory inputs and limits on the possible ways of integrating them. We don't know what dictates these options and limits, but it probably has something to do with information, with how it can be filtered from the environment, by what means that information acquires meaning, how it can be most efficiently organized and used, what types of embodiment enable its collection and use. What we'll need to understand better the shape of mind space and the parameters that define it is a real theory of mind, not in the classical psychological sense, but a science that can encompass and account for the origins and the operations of mind. This isn't the same as a theory of the human brain, in much the same way that a theory of how the internal combustion engine works is not the same as a complete predictive understanding of Ford Pontiac. It's probable that the former is, I think, a more profound account of what cars are about. And I suspect it might actually be easier. It's unencumbered with the endless minute particulars of how, say, the windows work or how to turn the lights on. It's one of the deepest mysteries in science that the universe can generate the capacity to know itself. There's nothing in the fundamental laws of nature that I can see, at least so far as we know those laws, there's nothing in them that hints at that capacity. And to me, it seems much more remarkable than the fundamental laws permit, say, the existence of black holes. No one has predicted minds from first principles. Yet I suspect that mindedness, as much as life itself, is an inherent characteristic of the universe. Whether it's rare or common is, in comparison, a minor question. That conscious matter exists at all has to make me wonder if there is at root some feature of information itself that will render that inevitable. Or perhaps we might turn that question on its head and wonder whether the laws, as we know them, are themselves contingent on the kinds of minds that perceive and articulate them. This could be one of the practical benefits of having a better view of the space of possible minds. It could broaden the horizon of our own minds, freeing us from the straitjacket of our convictions and the blind spots of our perception. I don't think we should take it for granted that cephalopods or bees or bats carve up the world in quite the same terms that we do. And they're just our neighbors in mind space. This is precisely why the biologist J.B.S. Haldane advised humility about how we imagine and depict the world in our schemes and our sciences. So he wrote, we're just getting at the rudiments of other ways of thinking. I do not feel that any of us knows enough about possible kinds of being and thought to make it worthwhile taking any of our metaphysical systems very much more seriously than those at which a thinking barnacle might arrive. As we extend our sensory modalities artificially, we realize how much we've been missing: X-rays and radio waves, gluons, gravitons, dark matter and antimatter. As Haldane famously went on to put it, let's get my suspicion is that the universe is not only queerer than we suppose, but queerer than we can suppose. And he went on finally to say this: our only hope of understanding the universe is to look at it from as many different points of view as possible. So for that, we may actually need other minds. Thanks very much.
Thank you very much, Philip. There are already a few questions in the chat. If you have more questions, please type them, and I'll ask Philip. I have one quick question. Do you consider yourself a dualist?
Well, if you mean in the sense that we can separate body and mind, is that really the...
Well,
or matter and mind?
At the beginning, you mentioned that you wouldn't consider a rock as having a mind. So also you mentioned, like many others, like for example, Jon Stewart has a paper from the 90s called Life Equal Mind, which is what you refer to as biopsychism. And it would be like saying, okay, if you are alive, you have a mind, but then there's also the debate on where does life begins and what is alive and what isn't. So let's say, I mean a dualism in the sense that you have some stuff in the universe which doesn't have a mind, and then how does the mind comes out of that stuff that didn't have a mind, and where do you draw the boundary, or is it gradual, or how would you separate them?
Well, I guess I would consider myself a materialist in that I don't feel there's anything magical about minds. I mean, there are some, I talked about biopsychism and plant neurobiology, and of course, as I'm sure you know, there's also, panpsychism has come back into fashion, where, there's this notion that actually perhaps everything has a mind, or at least that there are, many more things that have some degree of mind than just things that are alive. I guess I feel that, there's nothing magical about mind, in that I do think it is something that emerges gradually from the ways that matter can become organized, just as life does. And in parallel, probably, with the way life does. And by the same token, I'm open-minded about the ways in which life can emerge. I don't, and I know, there are plenty of astrobiologists who feel this way, that we shouldn't be too narrow in our view of what life is and how it can emerge, and that it has to be Darwinian or something. There may well be other ways that it can emerge, and I think the same is true of mind. It doesn't have to emerge as we've seen it emerge on this planet, but I do think that it is an emergent property of that kind of class, that it's something that appears by degrees, and in different, that's really why I'm sort of stressing this idea of mind space. It can emerge in different directions. So you could, I see no reason to suspect that a mind has to be like ours, only a little bit turned down or a little bit turned up. That it may be that there is a kind of that there are minds that are super conscious. There are minds that have immense amounts of memory. I mean, we see this. That's the point I was trying to make about birds. That actually, their minds aren't just sort of turned down version of ours. In some ways, they're turned up versions of ours in some dimensions, but turned down in others. So that's the way I think of mind. It's not a single thing. Mindedness, I think, is a useful thing to think about, but mind is not a single thing that you have more or less of. And I think that's why this notion of a space makes more sense than just thinking of it as a
Yeah.
single thing on a dial.
Yes, squirrels have better spatial memory than we have. So there's a question, were there any languages that can facilitate a representation of reality that is more complex than others?
Well, that's a really good question that I don't know that a linguist would have to answer. I mean, you know, the one thing I can say about that is that I think languages, in the small way, in our little, you know, cloud of mind space that we inhabit, I think we can already see ways in which languages do seem to affect our ability to conceptualize the world. So I know, for example, that there's a different spatial representation, and it's reflected in the language use in China of space, of time, sorry. That, you know, time isn't in front of us and behind us, it's above us and below us. And below us, if I remember rightly, below us Satyen is tomorrow, is later, you know. So it's to a Western mind that's kind of counterintuitive. To a, you know, to presumably to a Chinese mind, it's completely intuitive. So yeah, you know, whether the language is responsible for that difference in sort of the way we conceptualize the world, or whether it's the other way around, or whether the two co-evolved, I can't say, and maybe a linguist could.
Yeah. Sofia Flores asks, suggesting that human mind evolved to enable more diversity of behavior, isn't this a teleological argument? Is there a purpose of human mind, or is it the result of emergence?
Well, I mean, I don't think it's any more teleological than anything in evolution, really, in the sense that you know, it's more the fact that the evolution of cognitive capacities and of greater cognitive capacities created the possibility of inhabiting new evolutionary niches. You know, so that's really the way it's working. It's not, you know, as though somehow evolution said, oh, if I just gave these creatures, you know, the ability to conceptualize space in a different way, they could start living over there or in underwater or whatever. You know, I think that's obviously not the way evolution works. So that's really the way I mean it. That, you know, it's in that respect, it's no different from any other capacity that evolved. That it evolved by, you know, random mutation followed by natural selection because it gave an advantage and a new niche to expand into.
Yep. Another question by Mahuri Diaz. Plants have developed behaviors that some authors categorize as intelligent. However, plants do not have a brain as such. What kind of mind would plants have? Could we consider them conscious?
Well, as I say, that, you know, there is now quite an extensive literature on this. If you look up plant neurobiology, you'll see this discussion. It's quite a heated discussion, probably as heated a discussion as you'll ever see in botany, and a really interesting one, because you know, the argument is really about, it's not, I think it's more than semantic, but it's certainly about, you know, what qualifies as cognition and when cognition can be considered to, you know, require a mind. Because there's some say that to possess something like a brain with neurons is a precondition of having a mind. Others say, well, that's just dogmatism. You know, how do we know that? What's going on there, as I say, is signaling of a kind between cells. There are other ways that cells signal to each other. There clearly are. And, you know, in some plants, ways that seem to be long distance, that there is signaling, you know, down the phloem of plants, it seems, that, you know, pass signals from one end of the stem to the other. What's that about? We're not always sure, but it certainly seems to be, for example, signals of damage to a plant are transmitted to other parts of the plant to, you know, somehow tell the plant about it. Is that a kind of cognition? You know, is that an expression of mind? I think it's, I'm not persuaded myself that there's yet a strong case for talking about plant minds, but I think it's good that the discussion is happening, because I think it is quite right that, we recognize, I mean, in a sense, I think it is an expression of this fact that, we're not good at, well, we certainly shouldn't be trying to place a wall somewhere and everything on one side has a mind and everything on the other doesn't. And I think that there are absolutely, there is a space in mind space for plants, is really what I want to say. And there, just as there is probably a space for bacteria, it's probably going to be pretty close to the origin, but I don't think it's going to be at the origin. And I think in a way this makes it more, I think, a more productive discussion to have than whether it has a mind or not, because it's a way of thinking about the kind of cognitive, informational capacities that living organisms have.
Yeah, I remember hearing a few years ago someone who was specialized in plant cognition that all plant cells have electric potential. So in practice, they can function as neurons. So they don't have specialized nervous system, but they have machinery that allows them to transmit electrical signals, but in a much more distributed way, and not only within the plant, but across plants. So through the roots, they can also communicate with electrical signals and with chemical signals. So I guess also we're just beginning to learn, and also chemical signals through not only through the roots, but through the air, that sometimes they communicate like that.
Absolutely, yeah. And this generality of electrical signaling is really interesting. It's something that Mike Levin at Rutgers is working on a lot, and he thinks that it actually has a much bigger role, aside from neurons, than we've recognized for it. But as you say, Carlos, there's also that it's not just the plant that seems to be doing some sort of cognition, you could say. It's the ecosystem. They do communicate with each other. The fact that root systems resemble networks of neurons is kind of suggestive, but we shouldn't get carried away by that morphological resemblance. But nevertheless, it seems to be completely fair to say that organism, interplant or interfungal communication allows the whole system to do things like have memory, store information, have long distance conversation and communication and exchange of information. So there are absolutely capacities that operate at the ecosystem, at the forest level, that I think quite rightly are discussed in terms of cognitive-like behaviors.
Let me try to combine two final questions into one. One by Gabriel Ramos Fernandez. Do you think a collective of individuals could have a mind? For example, a market estimating prices, a group of scientists developing a cure for a disease? And a related question of minds at other scales, basically whether planet Earth could be considered to have a mind or to be conscious.
Yeah, well, both of those issues I discuss in my book, and they're both really interesting questions. I mean, there's a quite a nice and fun discussion, in the paper I started off with by Wegener and the Gray and Gray. So they include companies in there. They have a discussion in fact, in the book that Wegener and Kurt Gray wrote, The Mind Club. They have a discussion of, does Google have a mind? We talk about it as though it does. We talk about countries too, as what does China want? What do the United States want? We talk about it in that sense. We ascribe them a mind, and in some ways, I think it can be instructive to think about it, because on their plot you see that people feel companies like Google have a lot of agency. They clearly do. They can make stuff happen. Very little experience. And so, they don't feel that we don't have moral responsibility to them, but they ought to have moral responsibility to us. It's a way of thinking about where moral responsibilities lie. But I think it's a valid discussion to have, whether we can think about collectives of humans of any sort to possess some sort of, we talk again about hive minds and group minds and so on. And the question of whether the Earth has mind, and of course this is the an issue that comes up in the discussion of the Gaia hypothesis. Is it if biopsychism is right, and if the Earth can be considered a kind of organism, then Yeah, sure. I guess it does. And again, we sort of talk about, the Earth doesn't worry about us. It will continue without us. It's, we talk about it as an organism sometimes. And again, I think, and that's why you may have noticed I put it on that little plot right at the end let's sort of go back to it of, just this schematic view of mind space, just to raise that question. Is there a place for something, a complex system, incredibly complex system like a planet like ours? Is there a place in mind space for it? I don't have an answer to that, but I think it's a valid discussion.
You mentioned Michael Levin, so a question about xenobots popped up. Well, a first question might be whether these little creatures, are artificial living creatures, could be considered to have a mind. And the question is, could it be combined with our intelligence, with our consciousness? And will that make us stop being human?
Well, I mean, whether they're living entities, that's for sure. So, they fall within that same remit of discussion. They're relatively simple. They're small agglomerates of cells, but, there's no reason they should be excluded from that discussion any more than yeast are, for example. I think where perhaps this gets, even more interesting and contentious is when we think about brain organoids. And you might have noticed in the plot I had of Christoph Koch's mind space, genometric mind space, he included brain organoids. And I've spoken to Christoph about this. And in fact, part of the reason I did so was that these are my neurons. In fact, they're not just random neurons. They were grown from a piece of my arm because I had a brain organoid made from a piece of me. And it really made me think about these questions. Do I have responsibilities towards it? We know that these neurons are active. They're signaling to each other. There have been reports of brain organoids that seem to show some sort of concerted behavior that looks a little bit like the brain waves that we see in developing fetuses. And Christoph certainly feels that there will come a point where perhaps we're already there, where we need to talk about the possibility of consciousness, not just mind, but consciousness within brain organoids. And the better these models get, absolutely there's a motivation for thinking about that. There is a group of other researchers have talked about whether organoids are like islands of consciousness, or whether there are islands of consciousness within them, self-contained little units of almost like pure consciousness. So, I think that it definitely needs to be a discussion. And, I think it's quite right that Christoph put brain organoids into his mind space. And in fact, I did the same in mine. I think that's...
Well, Christoph is a panpsychist, so of course he will say that they're conscious.
Well, except that, I mean, he's careful about stressing that doesn't mean he believes that mind is everywhere, but only that it exists in a certain category of things that have a certain kind of connectivity between their interacting components. So, he doesn't believe that computers that we have at the moment have minds, or that they ever will have minds if we design them in this way, because they don't have the right kind of circuit structure, whereas organoids do. So he's a panpsychist in that sense, that you have to have the right sort of connectivity to qualify, but that doesn't limit itself to just brains.
Okay. Yeah. Well, thank you very much. It was a fascinating talk. And thanks for everyone who connected.
Oh, it's a pleasure. Thanks very much for asking me, Carlos. It was great to have the opportunity.
And in a couple of weeks, we'll have Takashi Kegami. There will be a change of time because he's in Tokyo, and let's say stay alert for the proper time and date. And thanks again, Philip.
Okay, thank you. Thanks.